Welcome back. Hope everyone had some good conversations at the expo while indulging in lunch. Remember that we would love your feedback at the end of the session. Scan the QR code shown at the end of the session and stand to win a limited edition swag from us. With this, please help me welcome Dennis Magzaho, Solutions Architect, Worldwide Public Sector, AWS, back to the stage.
Hello. Right, so good afternoon. I hope you guys had a good lunch. So I'm not sure if it's just like fate, but my sessions are always right after a meal. So I hope that you're comfortable enough or you're full enough to absorb, but not too comfortable to fall asleep. So we did serve a lot of coffee, right? So anyway, so for this particular session, we are going to go through an interesting topic. So this has been like the talk, or this has been, a lot of companies are doing this. So this is into machine learning, right? So, but machine learning is not really something new, in a sense that a lot of scientists, a lot of professionals have been into machine learning, right? And this is, of course, we have like, for the guys who have done computer science, right? We do have a lot of those problems that would require a lot of number crunching, a lot of data, etc. So that could be like learning, language, perception, problem solving, if you've heard about like computers playing chess and beating or competing with grandmasters, and of course reasoning. So we're trying to sort of mimic or understand how humans actually think and trying to put that in something like a computer, right? And have them do the work for us. But why has it been so difficult to do so? Right? So if you've seen some of the presentations earlier, one of them in particular was big data, right? So I think it can be broken down in a couple of things. One, data. For you to be able to come up with anyone doing statistics, right, or data science, hey, cool, right? So for you to be able to come up with accurate predictions or models, right, you need lots of data. And you need a place to store data. And you need the computing power to actually process data. So, and well, I'm not sure which generation you're in right now, but the storage was not really that cheap long ago. But as you can see, it becomes cheaper and cheaper. So now, we have a lot of options where we can store information or data. So in our particular case, we have AWS S3 or Amazon S3, where you can put in objects and have them as input. And at the same time, once the processing is done, you can put it back in. The second problem is computing power. So these algorithms, they usually require huge amount of computing. So whether it's CPU, whether it's GPU, it's still, for ordinary people, it's really hard to get those sort of resources and play with it, right? And one of the other things that I feel why it's hard was the data models themselves, right? So I've mentioned, I was asking who does statistics. More often than not, if you're doing machine learning, there's a good chance that your background is into that sort of science. Right? So it now becomes difficult, like, okay, what if I don't have a degree in statistics or mathematics? Does that mean I cannot do machine learning? Right? So those are what makes things very difficult for people, for the majority of those that are not taking those courses to do machine learning. Okay? So our mission is to put, oh, the color is different, put machine learning in the hands of every developer and data scientists, right? So we know that this technology would be helpful, and as much as possible, we make means or services for it to be accessible to customers, okay? And we are not really strangers, we're Amazon and AWS, when it comes to machine learning. If you know about like Amazon, if you shop in Amazon, the recommendations, right? So we have been giving recommendations based on, let's say, how you purchase history, how you click, what products you choose. So that requires some degree of machine learning. That's also true for Alexa, if you've seen the demo. Voice-driven interactions, right? So we have been doing that as well. And if you've seen the videos of Amazon Go, where you have like a store where you can pick up products and go out without having to go through the cashier, right? So those sort of things we have been doing. And of course, as mentioned earlier, we would want that technology or those capabilities to be available to our customers as well. Okay, so I'll be introducing the AWS machine learning stack, but as my presentation title indicates, I would be focusing on the one in the middle, which is Amazon SageMaker. But prior to going to SageMaker, I would want to at least emphasize that we do have a suite of machine learning services or offerings that are available to you. Okay? So briefly going through each one of them, of course, we have, instead of us reinventing or coming up with new frameworks, we'd rather that we provide something that most customers or people or developers are already familiar with. So that could be like Caffe, MXNet, PyTorch, TensorFlow. And that's interfaces like Keras and Gluon. So these are frameworks that we make available to you. Okay? Right, so in terms of the frameworks themselves, apart from just providing you with the frameworks, we, of course, would be providing the necessary infrastructure. So it's not just that, OK, I have the data model, so I should be able to do this. Right? But as I've mentioned earlier, it requires a certain degree of computing power to do these algorithms on this huge amount of data. Okay? So to make the frameworks available to you, we have what we call AMIs, or deep learning AMIs, Amazon Machine Images, that already includes the different frameworks. So I remember like a couple of, I think 2 weeks back, so I was trying to install OpenCV and MXNet. Right, so compiling takes a lot of time, takes a lot of resources. And I was doing it on a Raspberry Pi. So you just can't imagine. I live in the Philippines, so it's quite hot, so I have 2 fans right on the Raspberry Pi so that it doesn't overheat. So it takes a while, then I realized there's an AMI, and in fact, there are, if you're doing containers or Dockers, there are Docker images for MXNet. So that will make it a lot easier for you in any case. And also, if you would require a certain degree of processing, we make it available to you as well. So we have like, if you have algorithms that can leverage CUDA cores of Nvidia, then we provide the Nvidia Tesla V100 GPUs. Right? So these are things that you can readily spin up and shut down if you don't need to use it anymore. So we have customers that use that, so like Airbnb, Toyota, and OpenAI. So that's on the frameworks and interfaces, right? So why don't we go to application services? So instead of you installing or building things on the lower levels or the frameworks, we also provide you with services where you can just directly invoke and come up with inferences without you having to worry about what model am I using, how accurate it would be. Okay, so in terms of, let me get back to you on that one. The 2 icons, the first 2 is more on image. And then the next 1, 2, well, a couple of them, is more on voice, translation, and text. Right, so all of those areas, we do provide services to help out in you coming up or building your applications. Okay, so as I've mentioned, with image processing, there are use cases like, for example, law enforcement, where you can use Amazon Recognition and Amazon Recognition Video. So they will provide you with mechanisms to do inference, let's say for object and scene detection, facial analysis, search, celebrity recognition, and text on image. Again, without you having to do the heavy lifting of coming up, training your data, gathering all the data sets required to perform such operations. And they are API-driven. That means if you are working or using a programming language, most, if not all popular programming language would have APIs, SDKs to make this work. So if you're using Java, JS, Python, so they are readily available. Okay, so that's for the application services, and we discussed the frameworks. The one in the middle, which would be the focus, except the other one. But the other one, the Amazon Mechanical Turk, I'm not sure if, has anyone tried Mechanical Turks? Oh, cool, at least, yeah. Phew. So it's a 24/7 human workforce, right? So at first, I couldn't believe what it was, but yes, it's a human workforce. Imagine this is one activity that one of the SAs did in a previous project. If you're doing sentiment analysis, and in the case of English, should be okay. But I live in the Philippines, so Tagalog, when you try to get sentiments from Tagalog words, it's quite hard. We do not have existing data sets large enough to come up with accurate predictions. So a colleague of mine, what he did, he streamed Twitter feeds, and there are mixed English and Tagalog, and then that data is submitted to the Mechanical Turks, and there are actual people that would grade them. It's like binary classification where I would know, is this a positive feedback or is this a negative feedback? So the people would then just check positive, negative, and then it will come out. It's effectively you're coming up with your data that you can use for your data models, right? So it's just that, yes, we have sophisticated algorithms. Yes, we have powerful machines, but there are still tasks that only humans can do, right? Without buying, large, expensive servers and all that. So that's the Mechanical Turk. But of course, the focus of our discussions would be on SageMaker. But prior to that, so let's go back to machine learning. So machine learning is a series of steps. So generally speaking, 1, 2, 3, there's about 3 steps that you'll have to do. So, and there's a question of where do you actually spend your time on? Okay? So first part is building. Okay? So you conceptualize what you need to do. You come up with a question that you want answered, and then you gather the data sets. So the data sets, it could be images, it could be text, right? And then you, if you're familiar with the data science steps, there's what we call data exploration. So you need to know it's like a data behavior. Is it scattered? Is it clustered? Et cetera, et cetera. And then based on the data, you come up with the proper data model. Okay, so, assuming that I see this data, I think I'll be using clustering and k-means as my algorithm to sort of cluster them together. I need to train it now, okay? So you spend an ample amount of time on training. In fact, most of the time will be spent in training. And this is directly proportional to the amount of data that you have and also the processing power for you to crunch that data. And then once you trained it, it's not done yet. So you would see, okay, the prediction is not that accurate. So you need to tune the parameters such that eventually you have an acceptable tolerance on the accuracy of the data model that you chose. It's either that or you pick another data model, okay? And lastly is the deployment. So you deploy it somewhere. So if it's an IoT or Internet of Things, it can be deployed in a camera, it can be deployed in a Raspberry Pi, or it can even be deployed in your laptop, okay? And then the inference is where it happens. But of course, this goes on a cycle because once you deploy, you gather the ground truth or the actual observations, and then you feed it back to your training phase, right? So until you get acceptable accuracy when it comes to your predictions. So that's the process, but there's also the question of the quality of your data, right? So when you gather or when you get data, if it's raw, then chances are you call it in a way dirty, right? It's not in the right format. There are like attributes that I need to split into two, or there are attributes that I need to combine so that I can run my model on it, right? So these are the different challenges that you would have when it comes to picking your data. So data selection, you pick what is needed, what is not needed, depending on the question you want answered. Data cleansing is there as well. How do you handle nulls? I think there's this algorithm that if you're trying to find, sort of tune an image, and there are pixels that are jagged, you can actually use algorithms to smoothen them. So there's data absence in those jaggedness, but you sort of come up with an algorithm to smoothen it out, right, by providing additional data. You can annotate your data as well. And then, of course, when it comes to models, the challenge of picking the right model, because it's not like one model fits all. There are a lot of models, and you need, depending on what you want answered and the availability of data, that would sort of limit or dictate the data model that you can use. Then you evaluate, and then, of course, you deploy. OK, so that's why we go to Amazon SageMaker. So this is a service that we provide to help out in all the challenges and steps that I've mentioned earlier. OK, so going back to the 3 stages or phases that I described, with building, we provide you with notebooks. So anyone using Jupyter notebooks? Jupyter, anyone? Yeah, so mostly Python guys, I would assume, right? So we will provide you with the Jupyter instance. You would be able to start it up. And then there are available notebooks that you can use. So you don't have to start from scratch. We do have a lot of samples in that one. So a lot of I'll be going through the algorithms later as well. A lot of the algorithms are made available in SageMaker, right? So you don't have to develop them on your own. And then you can train and tune. As I've mentioned earlier, this would require computing power, storage to store your data before you can train them. So we have what we call one-click training, where you upload your data, let's say, to S3. And then when you click train, you just tell SageMaker where your data is, and then what data model you'll be using. And then there's also hyperparameter optimization, where if you're not sure, OK, this is a data model, and I'm not even sure what's the right parameter to put in, you can specify a range, let's say 0 to 5. And then SageMaker will tune your parameter to increase the accuracy of your model. And lastly, let's say, I've done training my model. I want to test it, or I want to deploy it. So you need a place to host, whether it's web-based or a cloud-based or a location or maybe a device you want to deploy it in. SageMaker could help out in delivering that model to the destination of your choice. All right? And all of that, since this is running inside the AWS infrastructure, you have all the compliance and audit capabilities available to all AWS services. And it's still pay-as-you-go, meaning if you train something, you get charged for using the resources for training. And after the training, you don't pay for the compute resources anymore. There's also end-to-end encryption. And if you would want, let's say you're already an existing Amazon user and you have a VPC or a virtual private cloud, and then you have resources within that VPC, and you have, let's say, apart from data workflow that I would need to check with this one, cross-validate, et cetera, then it has VPC support. Okay? So going back to the 3 steps, so I think this is the second time I went back to those 3 steps, but at least it's a little deeper in a sense that in terms of building, here's a screenshot of my Jupyter notebook. So I took this like 2 nights ago. This will provide you with an ID, with a development environment, so you don't have to build your own. If you're, let's say you're already using Spark, that's fine. We will provide APIs for you to integrate with Spark. But this is a Jupyter Notebook. It's hosted in AWS. And then on your right would be the list of algorithms that you can readily use, right? So this is a Jupyter Notebook. But is there something, well, it's too small to read. But if for those who are using R, that's actually R instead of Python, right? So it just so happens that I'm more of an R person than a Python person. So there's also a sample notebook in SageMaker where you can install the R kernel. So if you're an R sort of programmer or a data scientist using R, then in this case, I'm using ggplot to come up with the graphs. Okay, so there's some degree of flexibility that you can use, right? So that's for building. So this is actually the steps that I did. The last times I just took screenshots, so at least I can walk you through the process. This is the SageMaker dashboard. As you can see, I'm creating a training job. On training, you click training jobs, and then you specify, like in this case, the algorithm, I'll be using random cut first. And then at the same time, I will specify the instance types. So that takes care of the compute resource that you would require. And it will also ask you whether if it's one instance or additional volumes per instance, etc. So that's storage and also compute, right? So with this, you should be able to readily train your data. Okay? And of course, the last step is more on deployment. So on the inference side, so you have the notebooks, you trained, and now you have your models and you would want to do the inference. So on the inference side, as you can see, I just specified the roles, the name, and then I create model. On the far right, your right, that's like a diagram where you deploy the models. On the bottom is like the resources you use for training, and then it will deploy it on another set of resources. And as you can see, we have what we call endpoints. So if you want to do inference, once that's deployed, you can invoke that endpoint, pass parameters into it, and then it will use your trained model to do the inference. So that's on the deploy part. Okay? Oh, okay, I did mention. You can do a single operation inference, or you can do batch transform jobs. That means if I would want to do inference on multiple records, I can upload it to S3, and then use batch transform, take that as input, perform the inference, and then output it back to S3. So that's if you would want to do it by batch. Okay, so I won't be going too much on this one, but basically when you're doing SageMaker, most of the data challenges that was mentioned earlier, it helps you to do so. But of course, the human part, which is like exploratory, that's where the data scientists come in. Picking the right models as well is still human, if I may say so. Right? So that's SageMaker, and in a sense, we do have a lot of customers using SageMaker. And in this case, Intuit was using SageMaker, and they're doing artificial intelligence initiatives at scale. I would want to emphasize this in a sense that, yes, I see a Jupyter Notebook. But when you saw that I was like using instances, large instances, enterprise class instances to train my data model. So it's not like just a single tool that I can use for modeling. So I have had users who were saying that, okay, I'm a data scientist. I train my models on my laptop. But of course, the restriction is on the scale part, right? So I can only perform the training as long as the available hardware or instances can take the training. Okay? And then, of course, Digital Globe, which is, again, this is a company that uses a lot of data, specifically images. So they use this, they run it against, the training models are on petabyte scale, right? So you might be wondering, okay, it's a Jupyter notebook that can do petabyte scale, right? So because we've decoupled the training, so it's not like your Jupyter instance doing the training, it's actually a separate set of AWS resources that's doing the training for you, okay? And a lot of customer successes with Amazon SageMaker. So we have Dow Jones, GE, etc. Okay, right. So how do we put ML in the hands of developers, literally? Okay, so if you would want to really see it in action, in fact, anyone has visited the demo booth for the solutions architects, we have AWS Deep Lens. Okay, so AWS Deep Lens it's a mini computer with a camera, with a data model, right? With internet connection and connectivity for you to be able to manage it. So it's the world's first deep learning-enabled video camera for developers. So it's like giving you the opportunity to work with imaging, machine learning on imaging, without having to invest in huge amount of hardware just for video analysis and processing. So it has a fully programmable video camera. And of course, it has MXNet, Caffe, and TensorFlow, if you choose to. And it's not just the hardware, it's not just the concept or the algorithms, but we do have a lot of sample code that you can use, right? So if you want to play with different algorithms, there are different projects that you can deploy. So the educational models are there. And you can also do custom models. So when you go to Deep Lens, it will give you a couple of available projects that you can readily deploy into the Deep Lens itself. Now, connecting that or relating that to SageMaker, you can have a model trained in SageMaker and then have it deployed in Deep Lens. Right? So if you would want to refine object detection, because they are pre-built, but if you say, okay, but I want to train this more specific to my locale, right? So you can actually feed more images to it. Let's say if you would want to do facial recognition, you can feed images to it, do the training, and then deploy it back to Deep Lens. Okay, so because one of the challenges I have working with facial recognition is there are a lot of data sets available in the internet. You just Google facial expression analysis, and it will come up with a list, 60 databases. But my challenge is most of them are Caucasians. So I live in an Asian country. So there's very limited images that relates or mapping Asian features for inference. Okay? So with that, you would be able to feed it with new images specific to your locale, and then perform the training and then deploy it back to Deep Lens. So it's a two-way communication, so the data can be streamed back to AWS, and at the same time, integrate with other AWS services. Now, why would I do that? Because there are cases where I would want to split the inference in two. Like, for example, if I would want, this is a very simple example, if I want to classify the type of bird that I see, let's say, in a picture. So I can set a data model that would just detect for birds. And when a bird is detected by, let's say, Deep Lens in real time, it will take a picture and then send it back to AWS. And then you can do further classification with that image. Of course, there's latency, but depending on the requirements that you have, you can actually split the inference into two. And with that, the other services, whether it's a simple notification service, etc., is readily available to you. So as I've mentioned, there are pre-built projects that you can use. Artistic style transfer, I tried this. It's like, I'm not artistic, so I'm not sure what came out. But it sort of changes the scene into something like art. But art is subjective. But in any case, the other one is hot dog, not hot dog. This is a very popular algorithm where it detects if there is a hot dog or no hot dogs. And then, of course, object recognition. It has a limit, some set of objects that it can detect. But again, you can tweak the algorithms available and come up with your own custom algorithms. So in just this year, we actually came up with hackathons where they use deep lens and come up with their own use cases. So the second place is something that I was trying to recreate. It's like an educational sort of application where all the inference is being performed in deep lens. It has there's a line out to the speaker, and then there are pictures up front. Then the voice prompt will tell you, or the voice will tell you, okay, show me a picture of a dog. And then the child would have to raise the picture, and if it's correct, it will say it's correct. If it's not, then it would say try again. So that's a very interesting use case, and we do conduct this hackathon sort of to cultivate the creativity of using these services and these devices. Okay, so we do have a lot of customers running machine learning, so not just deep lens or SageMaker, but the stack that we have. And also something that I would want to emphasize, it's not just a single product. It's actually a set, and you are free to choose whether you would choose to use SageMaker or you just would want to deploy it on MXNet. So, and well, backtracking a bit when it comes to SageMaker, deep lens, in case, for example, that you feel that, okay, I don't want to use deep lens. As I've mentioned, you can actually do this with Raspberry Pi if you have one available. You can deploy it via Docker images within the Raspberry Pi itself, or you can natively compile OpenCV and MXNet. Now, once you have that, it will now have, of course, attach a USB camera or use the Raspberry Pi camera module. Now, it now has the capability to do inference. That's under the assumption that you already built the model. So to connect the building part, the SageMaker part, into your device, you can configure it to connect via AWS IoT. And with AWS IoT, you would be able to deploy your models from AWS going to your custom devices. So it doesn't really have to be deep lens, right? And with that, wow, we have about 2 minutes, but that's it. Thank you.